Okay, I've got an example of a limiting reactant with energy type reaction going on here. Sulfur trioxide reacts with water to produce sulfuric acid. It's got a delta H of negative 266 kilojoules, which means that this is exothermic. It's exothermic, so when I write the balanced equation, the heat term is going to go on the right side as a product. What we've got is 163 grams of sulfur trioxide reacting with 27 grams of water. We want to know how much energy is released in this reaction. First thing we're going to do is write a balanced equation. So we'll get started there. I've got sulfur trioxide, SO3, reacting with water to produce sulfuric acid, H2SO4. So I want to balance this. I've got one sulfur, 3, 4 oxygens, 2 hydrogens, 2 hydrogens. Bonus, this thing is balanced already. So what I want to do is I want to put my energy term into the problem. The energy term I said would go on the right as a product, 266 kilojoules. The sign right here tells us the side that it goes on tells us whether it's endo or exo. If it's positive, it's endo, and the heat is an ingredient or a reactant, it goes on the left-hand side of the reaction. If the sign is negative, then it's an exothermic reaction, and the heat will go on to the right-hand side as a product in the reaction. Once we take a look at the sign, after that we drop it. When it goes into the equation, it always goes as the absolute value or the positive version of this number. That's why it's positive 266 kilojoules. So now we're ready to go ahead and do our stoichiometry here. This is just like the other limiting reactant problems that we've done. What we're going to do is we're going to write down our givens. 163 grams sulfur trioxide and 27.0 grams of water. In both cases, my unknown is going to be my energy. I am looking for how much energy is released. So I am going to go to kilojoules in both cases here. Kilojoules and kilojoules. So first thing I'm going to do is convert from grams to moles. 1 mole sulfur trioxide over so many grams sulfur trioxide. I'm going to need to add this up. I know that I've got 3 times 16 for my oxygens is equal to 48, plus another 32.07 grams is going to give me 80.07 grams. 80.07 grams of sulfur trioxide. I'm pretty sure that's 32.07. Let's double check that here. Sulfur 32.07. Yeah, I was right. Okay. At this point, I can see that my grams of sulfur trioxide cancel. I'm ready to go ahead and get rid of my moles of sulfur trioxide and get into my energy. So what I'm going to do is I'm interested in sulfur trioxide and 266 kilojoules of energy. So the 266 goes on top, 266 kilojoules. The 1 mole of sulfur trioxide goes on the bottom. I'm using this just like I would a coefficient in any of my stoichiometry problems. So it's a 266 to 1 ratio. There's only 1 mole of sulfur trioxide for every 266 kilojoules of energy produced. So at this point, I can go ahead and cross out my moles of sulfur trioxide. I've got my kilojoules of energy. Let me go ahead and punch this through on the calculator. So I've got 163 times 266, hit enter, divided by 80.07, which is going to give me 541, for 3 sig figs. Yeah, 542 kilojoules actually. 542 kilojoules. Now, I don't know if that's my answer yet because, again, this is a limiting reactant problem. So what I need to do is figure out the energy that both of these reactants will produce and figure out which one will produce the least amount of energy. Again, it's just like a product. When I go to make that 1 extra kilojoule of energy, I will have run out of one of these ingredients and I won't be able to uh, do that reaction anymore. So I've got 1 mole of water over 18.016 grams of water. These guys will cancel. At this point, I can go ahead and go 266 kilojoules of energy over. Again, it's a 1-to-1 ratio. I'm interested this time in my water and my energy. So over 1 mole of water. Again, these guys cancel out. I can grab the calculator and calculate how much energy. So I've got 27 times 266, hit enter, divided by 18.016, hit enter, and that is 399 for 3 sig figs, 399 kilojoules. So again, it's the least amount that I choose. This is the amount of energy produced or released. Just like with the other stoichiometry problems, this is my limiting reactant. I'm not asked for it, but I'm going to go ahead and label it anyway. And this is the amount of energy released. It's the lesser of the two amounts because I'm going to run out of water before I can release any more energy, just like we did with stoichiometry.